In this opportunity, we are going to talk once more about the option value associated to a land, to a plot of land. As we mentioned in a previous video, the development of a plot of land can often be deferred. And this possibility adds value to the land, which is what we know as the option value attached to the land. We also explained before the decision tree method for quantifying the value of this option. In this presentation, we will present the conceptual framework behind an alternative approach, which is based on option pricing theory. First, let's review very briefly the concept of an option. There are two basic types of financial options: calls and puts. A call is the right to buy an asset, which is called the underlying asset, at a predetermined price, which is called exercise or strike price, at a certain moment in the future that corresponds to the time to expiration. A call is equivalent to ensuring a maximum purchasing price. An example of a call would be the right to buy a share of stock, say a stock X, for $10 within the next month, for instance. The value of a call at maturity can be illustrated through this graph. If I buy the call, meaning that I have the long position, okay, I will have this profit, or not really profit, this positive cash flow at maturity of the option. Let's explain. In the vertical axis, we have the positive cash flow that we obtain when we exercise the call, and in the horizontal axis, we have the value or the price of the underlying asset, in this case, the stock. E corresponds to the exercise price, so the amount of money that I should disburse in case I decide to exercise the option. So if at maturity the stock price is above E, for instance in this point, I of course will decide to buy it for E, which is a lower value, and I will have a positive cash flow, which is kind of a profit at maturity, equal to the difference between S and E. That corresponds to this vertical distance here. And if the value of the underlying asset at maturity is below E, so it's in this region, of course I will not exercise the call because I will never buy something for a price, in this case E, which is larger than the underlying value of the asset. So, my cash flow in this case will be zero. So this is the way we illustrate the value of a call at maturity. And well, the position of whoever sells me the call, the one who takes the short position, well, the graph will be just exactly the opposite. A put is the right to sell an asset, again, an underlying asset, at a predetermined price, an exercise price, at a certain moment in the future. An example of a put on a stock would be the right to sell the stock, say for $10 in 1 month. And a put is equivalent to ensuring a minimum selling price. The graphs at maturity of the put are the ones that we can see here. If I have the long position, meaning that I bought the put, I will have a positive cash flow at maturity equal to this vertical distance in case I exercise the put, which I will do only when the stock is worth at maturity less than E, in our example less than $10. And my positive cash flow will be just the difference between E and S. In case the value of the stock at maturity is above the exercise price, say $12, I will not sell it for 10. So my cash flow will be zero. And the graph corresponding to the person who has the short side, the short position, will be the opposite. Now let's explain real options. Real options are calls or puts attached to the net present value of projects. There are three very important real options. One is the option to expand. For instance, if I have a factory and things go very well in the future, I usually have the option to expand the factory. And this is similar to a call, because if I decide to exercise my option to expand, I will have to pay some amount of money. I have to invest an additional amount of money at that moment in particular, and it's equivalent to a call because I have to disburse money in order to exercise my call option. The other is the option to liquidate. Again, if I have a factory and things go very bad in the future, I always have the option, usually I have the option to sell or liquidate the assets corresponding to my factory. And I will do that when the present value of the future cash flows coming from the factory is smaller than the liquidation value. And that is very similar to a put. The amount of money that I receive, which is an inflow, if I decide to exercise my put option, is a positive amount of money, similar to what happens in a financial put. And the other option we want to explain is the option to defer. For instance, if I have a plot of land, I usually have the option either to develop the land now or to wait for some time in the future to develop it. So I have the option to defer the development. And this option is particularly important for us in this presentation because precisely that's what we are talking about. We are talking about the option value associated with a plot of land. So in particular, we are going to talk about the option to defer, or the real option associated with the option to defer. The value of the real options is determined mainly by these three variables here. First, the net present value of the project. In this case, the net present value of the project represents the value of the underlying asset. It's like the stock price in the case of a financial option. And this net present value of the project changes over time in a similar way to what happens with the share of stock. Well, when the net present value of the project is larger, the value of the call will be larger, the same that happens in a financial call. And the value of the put will be smaller, the same that happens in a financial call. When the volatility of the returns of the project is larger, well, both the call and the put will also have more value. And finally, time to expiration. The longer the time to expiration, the value of the call will be larger, and most of the time the value of the put will be larger as well. So in general, the way these variables affect the value of the option is exactly the same that the way it happens in the case of financial options. Now let's talk about the relationship between real options and net present value. The net present value approach is actually a special case that is valid only when both volatility is overlooked and all managerial decisions are taken at time zero. What we mean by this is that the net present value approach is very similar to a call and maturity. Look back to the graph for a call and maturity, which is the gross line here. If you assume that S is the present value of the project at any moment in time, and E is the investment that you have to make in case you decide to, for instance, develop land. Say that you are thinking about the possibility of deferring development of a land. Well, E is the opportunity cost of the land, so the amount that you have to pay in order to develop the land, and S will be the present value of the project. Well, if the present value of the project is larger than the value of the land or the value of the investment, you invest and you have this positive cash flow. If the value of the project is less than the investment, in this case E, then you do not develop and your cash flow is zero. So you see that it is exactly the same that we had with the call at maturity. So summarizing, a net present value resembles the value of a call at maturity. A negative net present value project is equivalent to an out-of-the-money call, since the underlying asset is worth less than the investment outflow. The underlying asset is the present value of the project. A positive net present value project corresponds to an in-the-money call. because the value of the underlying asset, in this case, the present value of the project, is larger than the investment, E, the exercise price. When we have volatility and time, which is what happens, for instance, when we have the option to defer the development of the land, okay? We have a time in which we can defer it, and also there is some volatility associated with the returns of the project's net present values, okay? So when we add volatility and some time, then we are talking about an option which is not at maturity, okay? A real option, an option which is alive. So the value of the land will be represented by the value of the option before maturity, which is this line over here. So we see that the value of the land we have two components. One component is the intrinsic value of the option, which is how much I get, what is my positive cash flow in case I decide to exercise the option, plus a small amount here, which is the time value of the option, or the value of the option, the time value of the option associated with the project, or the land in this case. In a previous video, we showed that in equilibrium, the value of the land equals the net present value of the property's free cash flows. Well, this was true assuming that we don't have an option attached to the land, that we cannot defer the development of the land. So in the presence of risk or uncertainty, the value of the land and its associated project corresponds to the value of the call to develop it, which is always larger than intrinsic value, yes, because you have this additional time value of the option. The value of the land, including its option value, can be approximately modeled through option theory. Unfortunately, the models are beyond the scope of this presentation, and we will not explain the models in detail. So let's conclude. The development of a plot of land can often be deferred. This possibility, as we explained before, adds value to the land. So the land has an option value. In a previous video, we explained the decision tree approach for quantifying this option value. In this presentation, we have explained the conceptual framework behind an alternative approach, which is based on option theory. And this is all I wanted to share with you in this opportunity. Goodbye.